All right. Did you guys have any questions on homeworks? Yeah.
The quiz tomorrow is just over that arc homework that you emailed us, right?
The quiz tomorrow would be in class 1 would be on arc length. The homework that I sent by email, and then you'll be turning in what is that? The one that I made with my handwriting, right? So yeah, 2 of them. So any questions on any homeworks? No.
Can you do arc length per C?
What's that?
Arc length per C.
Could you tell me what that is? So you're asking a question from arc length homework. It is part C, right?
Yeah.
And go ahead. Y is what?
Y equals 1 plus x to the 3 halves.
1 plus x to the 3 half.
6x.
6. Okay.
0 and 1.
X is between 0 and 1. Is that it? Okay, so he is asking the question part C from the arc length question. So the arc length L in this case will be given by integral. What's the lower limit? The upper limit is 1. And then I have the integrand is a square root of, what's the first term? 1. And then plus, this would be the dy, this would be dy dx squared, right? And now what is dy dx? Dy dx is, it will be 9x to the half, right? And then I have to square that, right? Everybody's okay with that? Because what's the derivative of y? It's 6 times 3 half times actually what? Actually half, right? 3 half minus a 1. So you're getting 3 times 6 divided by 2, which is 9 times actually half. So that's what you have. And then this would be 1 plus 9 squared is 81, and then x. Okay, so how do I integrate? How do I compute this integral? What's that? What is u? Yeah, so you look at this integrand, and then your wish would be that this is just x, right? If this was just x, you know how to do it. And it is almost x, right? If you didn't have that 1, it is almost x. So that tells you that you want to do a substitution where you take u to be 1 plus 81x, and then du would be 81 dx. And so I could say this integral is equal to, I can replace 1 plus 81x by u. Now what should I replace dx with? 1 over 81 du, right? So 1 over 81 du. And so this is 1 over 81 integral from 0 to 1. This is u to the half du, which would be 1 over 81. U to the half antiderivative is what? Half plus 1, right? So that's 3 half. But then you have to divide by that. So that means you're going to get what? 2/3? U to the 3 half from 0 to 1. And then you plug in 1. If you plug in 0, you get 0 for sure. So then you get... Oh, I was just checking, right? No. I forgot. So I didn't change the limits of integration, right? So that's a big mistake. So here's my u, right? So if remember, this limits are for x, right? So when x is 0, what is u? U is 1. So let me use the eraser here. And so what I get then is u is 1, and when x is 1, u is 82. So I get 82 here and a 1 here. So this would be a 1, this would be an 82. So what I get is 2/3. You know what? I'm going to factor out the 2/3 as well. So 2/3 u to the 3/2, 82 and a 1. So what is that? 2 over 243. And here, if I plug in 82, I get 82 to the 3/2. And then if I plug in 1, I get 1, right? You can just leave it the way it is. Approximately what this is, if the 82 is approximated by 81, then this is about what? If I replace 82 by 81, right? About the same, 82 and 81. So 81 to the 3/2, 81 to the half is what? 9, and 9 cubed would be? What's that? 9 to the 3, right? So 9 to the 3 would be 729. So 729 minus a 1. And then what is that? This would be 243 times 228. Oh no, 728. 728. Okay, so I mean, you could have left your answer here. Okay, I just wanted to see approximately what that is. Right here. Yes. Yeah. All right. Anything else? All these steps made sense? Any questions on any of the steps?
It probably would have taken longer, but if you messed up at the very beginning and did like trig substitution,
Trig substitution would not work here.
Okay.
For trig substitution, you need x squared, right?
Well,
if you had 1 plus 81 x squared.
Okay, the step above it was x squared.
Okay, so if you replace, then what you have to do is you have to replace that x to the half by a trig substitution, right?
Right.
But the problem is, if you take x to the half is say tangent, right? Then when you take dx, right, it's not just dx, right? It is the derivative of x to the half. So it will be 1 over 2 root x times dx.
Right.
And you could still do it,
Okay.
but you will be making it way longer than it needs to be. Yeah. Okay, any other questions? All right, if you don't have any more questions, what I'm going to do is continue with section 10.2. Section 10.2, we have just one last topic, which is the following. Let's say again that I have a curve C, and let's say that x is equal to x of t, y is equal to y sub t, and so let's make a graph here. Okay, so let's say that the curve the curve looks like the following. Okay, and let's say I have a point here, and I have another point here. Let's say these 2 points are obtained at time t equals to a and at time t equals to b, and the curve is traced in this direction from a to b. Okay, and so let's say the value of x at time a, let's say at time a the x value is alpha, at time b the x value is beta. Is my picture clear to you? At time a the x value is alpha, at time b the x value is beta. So suppose that the curve is above the x-axis. Suppose that the curve is above the x-axis, and in this time interval the curve represents a function. The curve represents y as a function of x. Within this time interval from a to b, the curve that you have, the portion of the curve you have, it represents y as a function of x, right? Because it satisfies the vertical line test, right? So my question to you is, what is the area between what is the area below the curve above the x-axis? What is that area? So here the integral, so the area A, well, think of y as a function of x, right? In that case, what do you integrate? You integrate the height of the curve, right? From x varying from alpha to beta. So the area would be that x goes from alpha to beta, and then you integrate the height of the curve, which is y, and you integrate with respect to x, right? Isn't that what you usually do in Calc 1, right? You have a function f of x, right? And then you integrate with respect to x of f of x, right? So f of x is y in this case. However, we don't have a formula for y in terms of x, right? Because we have a formula for x is x of t, y is y of t. So we have a formula for x and y in terms of t. We don't have a formula for y in terms of x. So what do? Well, we are going to make a substitution here. We are going to replace x. Oh, by the way, what this integral is, then this is alpha to beta. It is y as a function of x dx, right? Y as a function of x dx. Now I'm going to make a substitution here. I'm going to replace x by x of t. I'm going to replace x by x of t, and then what would be dx? Dx would be x prime of t dt, right? So then I could say this is integral from alpha to beta, y, replace x by x of t, and then dx by x prime of t dt. However, what is y of x of t? Oh, I better be careful here, right? This alpha and beta would be what? Because I am making this substitution here, right? Now, when x is alpha, what is the time? Time was a, right? When x is beta, remember I said when x is alpha, time is a, x is beta, time is b, right? So I have to change that. And then what is y of x of t? Well, that's the same as y as a function of t, right? I am expressing y in terms of t. Are we okay with that? Because I'm expressing, when I evaluate y at x of t, I am writing the function y in terms of t, right? So that's got to be y of t. So that's my formula for. So if I want to find the area below a parametric curve, for t between two values, then the formula is this. I integrate y of t times x prime of t. Is that making sense? Let's do an example, okay?
So,
Yeah.
why is
Yeah.
y of t equal to y of x?
Y of x of t.
Why? But
So whatever.
y of x of t from where?
I'm sorry?
Where did you get y? Right.
So what I'm saying is we are integrating y of x, right? So suppose that x is given in terms of a formula in t. So then if I replace x, so suppose that y is like x squared, right? And then let's suppose that x is equal to sine t, right? Then if I evaluate y of, so this is x is x of t, right? So if I look at y of x of t, what do I get? I get y of sine t, and then I get sine t squared, right? So my point is I am expressing the function y in terms of t when I do that. So that's the same as y as a function of t. Okay, so let's look at an example to make this clear. So let's say I have, remember that we had this curve, I went over this curve in the class. Let's say I have the curve C, and then x is, let's say, t squared, y is t cubed minus 3t, and we drew the, we sketched the graph of this curve, right? And what did we obtain? We obtained something like the following. Whoops. Okay, so here's what we have. So the graph was like this. So this is t equals to 0, and let's say this is t equals to 3, and the graph was like this. So what we had is that so the curve is traced in this direction, comes around, and gets out in this direction. This point, first time it is traced at time negative root 3, and it is also traced at time positive root 3. Okay, and then it reaches this point at time 0. Okay. If you look back in that example, you'll see that was the case. So now suppose that I want to find the area, the highlighted area, between the x-axis and the curve in this loop. So how do I find that area? What should be the area there? So the x value, this point here that I have, that point has coordinates 3, 0. So the x value there is 3, the y value is 0. Of course, this point here is 0, 0, right? So what would be the area? Well, notice that x is going to vary from what? 0 up to 3, and then I have to integrate y dx. However, I have to express it in terms of t. So notice, at what time do I obtain the lower limit 0? When is x 0? At time 0. So t goes from 0. And when is x 3? you have to take negative root 3, because remember, it comes up, and at negative root 3 is the first time it hits this point, and then it comes to this point here. Okay? So you have to go to negative root 3. And then, what is y of t? Well, you're going to integrate y of t multiplied by x prime of t dt. Y of t multiplied by x prime of t dt. So what is that? Okay, what is y of t? What was that? T cubed minus 3t, and then the x prime of t is 2t. Okay, and then how do we integrate that? We can multiply out, right? Yeah, so 2t to the 4 minus 6t squared dt. And then antiderivative is what? The antiderivative, it will be 2 times t to the 5 divided by 5, right? And then minus 6 times t cubed over 3 from 0 to negative root 3. Okay? And let's see. And then you just plug in, right? So if you plug in, first of all, let's write one more line here. 6 and 3 will give you a 2, right? What's that? Flipped what? Oh, it doesn't, it wouldn't matter. If you flip, then you have to introduce a negative sign. Yeah. And then you need to, well, that was a 2, and then you can factor out the 2. And then you have t to the 5 over 5 minus t cubed between these two values. Okay? And then I'll let you finish this. This is, what are you going to do? You're going to plug in root 3, and you're going to plug in 0, and then you're going to subtract, right?
When's the right first to stop it?
Was that? No, you have to plug in.
Okay.
Yeah, I'm just stopping here. I'm just saying finish it off. But if you plug in 0, you of course get 0. So all you have to do really is plug in root 3, right? If you plug in 0, you get 0, yeah.
What's that intersection?
Oh, that's the area. That's this area, highlighted area. Yep. So we were trying to find that area basically. Okay. Any questions on that? Yes.
So you have it from 0 to negative 33.
Yes.
In that order because
I have to see how x. So usually when you take the suppose I have the graph of a function f of x, right? And I have x is going from, let's say, alpha to beta, right? So what is the area here? In Calc 1, didn't you learn that the area would be, you integrate the function, right? So that gives you the area. So here, remember alpha, x varies from lower to upper, like lower value to an upper value. So in this case also, x got to go from lower value to the upper value, but I get the lower value at time 0. I get the upper value of x at time negative root 3. Does that make sense? Okay, any other questions? Any other questions? Questions? Yeah, if you go from 0 to positive root 3, you're looking at the bottom one. What's going to happen then? You're going to get a negative of the Because when you have, suppose I have a curve like this, right? Suppose I have a curve like this. When you integrate this curve, right? When you integrate this function, you get negative of this area, right?
With the area at the bottom is not the same.
They are the same. They are actually symmetric, yes, yes.
So like, it's kind of like the
Mhm.
manifold is like 0, 1, yeah. Because normally you switch them, so it's just...
Yeah, it's just that the one that you want to make sure is that x is going from a lower value to an upper value to make sure that you get the positive area, and then choose your t accordingly. Am I making sense?
Yeah.
So because it's parametrically given, so basically what we are doing is really we are when I go from 0 to negative root 3, we are actually traversing the curve in this direction. Am I making sense? We are actually traversing this way. Even though the original curve was traversed this way, it doesn't matter because we have the same curve, same part. Yeah. So by going from 0 to negative root 3, I am actually traversing the other direction, clockwise. Okay, any other questions? Any other questions? Okay, so if you don't have any more questions, this is it for section 10.3. Sorry, 10.2. And the next section is section 10.3. Section 10.3. Section 10.3 is on so far, some of you might have seen this before, but so far you have only used rectangular coordinates, right? Whenever you talked about coordinate systems, you used rectangular coordinates. This section is about what we call polar coordinates. Polar coordinates. For some reason, last time when I taught Calc 2, by this time students are pretty tired, and at this point a lot of students stop doing their homework. So last time in the exam, the third exam, when I asked questions from this section, lots of people couldn't do them. And I actually asked pretty easy questions. I'll tell you what questions I asked as we go. And you'll see these are pretty easy questions, but still people couldn't do them. It's not because they weren't smart, it's just because they didn't do the homework, okay? So the warning is also that polar coordinates, if you go to Calc 3, you'll be expected to understand polar coordinates, okay? They will use polar coordinates to evaluate double integration, triple integration, and so on. So in Calc 3, one of the topic is, here we are integrating over an interval, right? In Calc 2, you will be integrating over a region in the plane and over a space in 3 space. Am I making sense? So you have this idea of double and triple integration. And when you do that, you can use polar coordinates to evaluate some of those integrals. So you'll be expected to know this there. Now the question is, what are these polar coordinates? First of all, let's recall what we know about rectangular coordinates. So in rectangular coordinates, what we have? We have 2 intersecting vertical axes, right? 2 intersecting vertical axes. Oops. 2 intersecting vertical axes. Each one is a copy of real number line. Each axis is a copy of real number line. Usually we call one of them x-axis, the other one we call y-axis. And again, these are they intersect vertically, and each one is a copy of the real number line. Now, how do I? If I have a point P, right? If I have a point P, what are the rectangular coordinates of P? So if I say that the first coordinate is x, the second coordinate is y, what's the meaning of x? It is the distance from what? It's the distance from, not from the origin, y-axis, right? So the distance from here to here is x, right? And the distance from here to here is y. So x coordinate is the distance from the y-axis, y coordinate is the distance from the x-axis, right? So this is what we have, rectangular coordinates. Everybody understands that? Okay, so given a point, how many different rectangular representation does it have? If I give you a point P and ask you how many different rectangular representations does the point have? Just one. This is a unique representation, right? Just one. However, when we do polar coordinates, things are more complicated. And you might say, why do we even bother to look into something more complicated when we have something so simple? Even though something is more complicated, it sort of helps us simplify many things in Calc 3, for example. And I'll give you some examples what it simplifies. So let's now look at polar coordinates. Polar coordinates. You still have two different coordinates. So now, in this case, imagine that you have a real number line, which I'm going to call x-axis, and now let's say the origin is right here. Let's say the origin is right here. The number 0 is right there. And now imagine that you have, let me highlight this for a second. Let's see, what can I use? Let me use this. Okay, now now imagine that I have another axis. Now let's imagine that I have another axis. I am going to call that polar axis or a rotating axis. So imagine that initially the polar axis is going to coincide with the x-axis. So right now the polar axis is on the x-axis. So let me draw that. Let me use a different color here. Let's so right now, let's say the polar axis is right on the x-axis, okay? The green one. And so let's say now I have a point. Let's say now I have a point P, and the point P is, let's say, right here. Okay? And I want to know what are the polar coordinates of this point. Well, what you're going to do is your polar axis, the green one, right now it's on top of the x-axis. You are going to rotate it until you intersect the point P. So rotate it until you intersect the point P. So this is the position of the polar axis now, right? Everybody is okay with that? So let's say in order to get to this point P, you needed to rotate by an angle, let's call that theta. So you needed to rotate the polar axis by an angle theta to get to the point P. Okay? Now remember, the polar axis itself is a copy of the real number line. So this is the origin for the polar axis as well. Okay. Now what are the polar coordinates of the point? Well, one of them is, what's the distance from the origin? Let's call that r. So the distance from the origin, okay, that's r. Right, that's this real number line, right? Because the polar axis is a real number line, so this is the real number r. Okay, and then the second coordinate would be theta. The second coordinate would be given by theta. Now P is the point. P is the point, and we are writing down the polar coordinates of the point P. Yes, rotationals, yes. So again, how do I write down, how do I come up with the coordinates of P? I revolve my polar axis until I hit the point P. Then I look at the distance from P to the origin. That would be my r. And the theta would be how much angle did I have to rotate. Is that clear? Now, the complicated things occur. So this is the positive side. So polar axis has two sides. One is the positive side. The positive side of the polar axis is this side. And this side here is the negative side of the polar axis, right? Okay? So the complication arises here. Now remember, when we talked about the rectangular coordinates, each point has a unique representation, right? But uniqueness disappears here. Why? Notice that what would be another representation of this point P? Yeah. Yeah, I'm gonna get to that point in like another 20 seconds. Let me say another point. The point I wanted to make is that instead of picking theta the way I did, right? I could have picked theta to be what? I could rotate the axis once and then come back to this, right? What is that angle? Theta plus 2 pi. Right? So this point P also has the coordinate. The polar coordinates could be written as r comma theta plus 2 pi. Not only that, I could have rotated couple of times, right? Couple of times. So I could have said this is r comma theta plus 4 pi. And this would be r. Generally, I can say this is 2 times n times pi, right? So how many polar representations do I have? Infinitely many, right? For every value of n, I get a polar representation of that point. Yes?
If you rotate it around the other direction.
Yeah, I was going to get there. That's where he went, okay? So another thing I could have done was that instead of rotating counterclockwise, I could have rotated clockwise, right? So that's what he is saying. So there are a couple of ways to do that. Let me make another picture. Well, maybe I can put it in here. Let's see. So let me use another color here. So another way you could have rotated. Yes.
Is the x-axis like below the polar?
No, the x-axis I wrote it down because x-axis is the initial position. There is actually one axis that I need. That's the polar axis. X-axis is just the initial position of the polar axis.
So like, if it would be below the polar axis, like it could, like it's still not on like the x-axis.
Yes. Yeah, we are going to now rotate the other way. So here's what we are saying. What if I rotate like this? I can rotate in this direction and come to this point too, right? Can someone tell me what is that angle? It will be theta minus 2 pi. Because it's a negative angle, right? It will be theta minus 2 pi. So I could have said that P has coordinates r, comma theta minus 2 pi. I still haven't I haven't covered your point yet. Everybody is clear on that? I could have rotated the clockwise and obtained this angle. And then once I get theta minus 2 pi, I could also say this is what? R comma theta minus 2 pi. And I can add any multiple of 2 pi if I wanted to, right? Which would be, it doesn't matter. Okay. Now, another way of thinking about, another representation would be the following. You see, in all the representations that I have so far, R is positive, right? R is positive in all the representations. But I could also make R negative. How? Well, let me make another picture now. Okay, let's say I have the point P now here. Yeah, I don't know why I made the y-axis here. Let's say this is the origin here, and let's say the point P is right here. And one way I can rotate so let's say I'm going to rotate my polar axis until I get to this point. Maybe I could use a straight line here. That's pretty bad. I'm just going to do it by hand. Okay, so this is, let's say this is the polar axis. Now, instead of rotating it counterclockwise, what if I rotate it clockwise by this much? Right? Then what's the positive side of the polar axis? Where is the positive side of the polar axis? In the bottom. But my P is still here, right? And the distance from the origin is now what? It would be negative, right? Whatever R I had before, it would be negative of that. So it will be negative R, comma, this is theta. Well, this is not, if I relate it to the previous theta, what would be this theta? What would be this angle? Remember this, we call this angle theta, right? So this would be theta minus what? Pi. Theta minus pi, right? So I could say this is theta minus pi. In fact, not only that, I could have also said this is negative R, theta plus pi, right? Why? Because what if I rotate like this, right? Then I get theta plus pi. Am I making sense? Then I can make the first coordinate negative R. Is that making sense? So not only I have infinitely many theta values for the same point, I also have two different possible values of R for the same point. Am I making sense? Any questions, anybody? Yeah. Go ahead.
Why would you want
because there are so when we look at polar equations, so equations involving R and theta, allowing R to be negative makes things more natural, like there is a continuity in it. Otherwise there wouldn't be a continuity. Okay, we'll see some examples where it'll be more clear. Okay, so next time I'm going to be going over more examples on this and so on.